Good morning, Year 7. Today we're going to be looking at solving equations, which our previous work on functions will be very useful for. So what is an equation? An equation is two expressions which are separated by an equal sign, and that equal sign shows that the two expressions have equal value. All of these are equations. You'll see that some of them have more than one variable. However, we're going to be looking at those which only have a single variable. In order to solve an equation, we need to find out the value of the variable in that expression. Here's an example. X plus 5 is equal to 17. If we want to find the value of that variable x, we would like to rewrite our equation in the form where we have x on its own on one side of the equal sign, and then a value on the other. Now, it may be easy for you to see at the moment with fairly simple equations, but it's good to have a reliable method that we can use later on for more complex equations. I'm going to use the bar model to show what we're going to do. We have x plus 5 is equal to 17. Now we can see clearly that if we chop off that 5 from the top and the bottom of the bar model, which is the same as subtracting 5 from both sides of our written expression here, equation here, then you can see that we will be left with x on its own being equal to 12, because here, if we have x plus 5 subtract 5, we have x on its own, and then on the other side of the equal sign we've got 17 and we're subtracting 5 from that, which is equal to 12. So it's really important that you recognize whatever we do to one side of our equal sign, we must do to the other. We're using the inverse operations here to help us. You'll see we have x plus 5, and we have used the inverse operation of addition, which is subtraction, to help us find x. Let's look at another equation. So here we've got 3x is equal to 12. Again, we want to rewrite this in a form where x is equal to something. So here we have 3 lots of x in our bar model being equal to 12. You can see we've got 3 x's which are of equal size. So if we chop that 12 into 3 equal parts, i.e. we divide our 12 by 3, then we are left with x is equal to 4. So we have divided both sides of the equation by 3, and we are using our inverse operation. Here we had 3 multiplied by x, so 3 lots of x, and now we're using the inverse of multiply. We're dividing to get x on its own equal to 4. What about if we have an example including a negative number? So here we have x subtract 4 is equal to 16. It's a little bit different to represent using a bar model, but here we go. We have our x, and because we are subtracting 4, we're going to put the 4 on the underneath. And then that 16 is there as well. So you can see that what we are doing is we're adding 4. We're using the inverse operation to subtract. We're adding 4 to both sides, which gives us a value of x being equal to 20. It's important to recognize that the value doesn't have to be an integer, which is a whole number. So here we have 3x is equal to 2. Looking at our bar model again, we've got 3 lots of x is equal to 2. 2 split equally into 3 parts. We divide it into 3 parts, which gives us a value of x is equal to 2 divided by 3, or 2/3. And we write our fractions in this form. Now remember that we're using the inverse operation to help us. So looking at this example, what's the inverse operation that we need to use? Have a think. Yep, that's right. So we have x divided by 3 is equal to 6. So that means that we're going to have to multiply both sides by 3 using the inverse operation. We multiply both sides by 3, we'll get x on its own. 6 times 3 is 18. Here are some questions for you to have a go at. Most of these are fairly quick to do, so I am expecting you to do all of them if possible. I would like you to show me your working. So like we did in the written method, show which operation you are doing to get that variable on its own. Pause the video and then you can move on when you're ready to get the answers. And here are your answers. Make sure you self-mark using a red pen if you've got one, and have a great day. Any questions, do let me know.